Welcome everybody. Today we're talking about triangle inequality. Triangle inequality specifically talks about the side lengths of a triangle. Now in class we did a little bit of an experiment where we measured the side lengths of some triangles and compared the data. We found that if we add the two smaller sides together in order to make a triangle, they have to add to be greater than the largest side of a triangle. So if we look at this example here, we notice that if we were to take this small side and this small side and add their lengths, it would be less than the longest side, which is why we don't come up with a triangle. And over here, the same idea is happening. If we were to add these two sides of a triangle, or what we're hoping to be a triangle, if we add their lengths, it's less than the length of this longer side, which is why we have an extra piece hanging over. So neither of these two things are triangles. But when we look at this triangle, if we were to add the length here and add the length here, they're going to be longer than this third largest side. So the triangle inequality theorem says exactly that. It says the sum of the two smaller sides must be greater than the longest side. Now, in case you're curious about, well, what happens if they're equal to the longest side? If they're equal to the longest side, this is what would happen. Let's say that we have the longest side right here. Okay, let's say it's worth 5 units. 1, 2, 3, 4, 5. Okay, if I was to have one side that's worth 2, and I was to have another side that's worth 3, it would just create a straight line. We couldn't make a triangle out of that. As soon as we started to open it, it would end up having a gap like we see over here. So it must be specifically greater than the longest side. So let's use that to answer a couple of problems. Okay, our instructions on these types of problems are as follows. Is it possible to make a triangle with the given side lengths? So what we're going to have to look for is we need to look for the two smaller sides. We need to add them, and if they're greater than the third side, then we can make a triangle. If it's equal or less, doesn't make a triangle. So let's look over here. Here we see that our two smaller sides are 9 and 4. So if we add 9 plus 4, the question is that greater than the largest side of 12? Well, 9 plus 4 gives us 13, which is greater than 12. So yes, we will make a triangle out of those sides. Let's take a look at another one. If we take the two smallest sides, which here is 3 and 3, and we add them, the question is that greater than 6? Well, 3 plus 3 is 6. 6 is not greater than 6. It's equal to it. So no, we cannot make a triangle with those particular side lengths. Okay, let's try one more. Here, my two smaller sides are 5 and 8. So is 5 plus 8 greater than my largest side of 18? Well, 5 plus 8 is 13, and 13 is definitely not greater than 18, so no, we cannot make a triangle. So take a second. There's 3 more problems here. Pause the video, see if you can come up with the correct answers, and we'll discuss them in a second. Alright, so how did you end up doing? You should have found that your two smaller sides were 5 and 2. 5 plus 2, is that greater than our largest side of 10? Well, 7 is definitely not greater than 10, so no, we cannot make a triangle here. Let's take a look over here. My two smaller sides are 13 and 13. When I add them, are they greater than the largest side of 26? 13 plus 13 is 26. That is not greater than 26. Those are equal. So again, no, we cannot make a triangle. And let's try this last one. Here we see that 14 and 8 are the smaller sides, so we're going to add those. Are they greater than the largest side of 21? Well, 14 and 8 gives me 22, which is definitely greater, than 21. So yes, these three sides will make a triangle. Now these aren't the only type of problems that we'll see. Okay, we do see problems that ask us to find a range for x. Now what that means is we want to find the smallest value of x that we can, the largest value of x that we can, and anything in between will also work. So here we go. They're giving us 9 inches and 14 inches of two given side lengths. So we want to know what's the smallest possible value and what's the largest possible value that we could choose in order to make a triangle with these given sides. Well, here's what we're going to have to do. We're trying to figure out x. And we can assume two things. We could assume, first of all, that this is the smallest side. Okay, if this is the smallest side, that would make 14 the largest. So I would have to add 9 plus x and make it greater than 14. Now, if you've never worked with an inequality like this, we're just going to treat this like a regular equation. This is our equal sign for the time being, and we're going to work just like we would a regular equation. Okay, so here to get x by itself, I'm going to subtract 9 from both sides. That's going to give me x greater than 5. Okay, so that tells me that 5 is the smallest value, okay, and anything else that I want to use has to be larger than 5 or greater than 5. Okay, so that's my smaller boundary. That's my lower boundary. Then I said that there's two things that we can assume. The second thing we can assume is that this is our largest side, which would mean that these two are the smaller. So 9 plus 14, is that greater than x? Okay, well I have x isolated already, so let's just add 9 and 14. 9 plus 14 is 23. So what this is telling me is that x has to be less than 23. Over here, x has to be greater than 5, but it has to be less than 23. So our final solution for this is 5 has to be less than x, and x has to be less than 23. That is the range of possible values that we could choose. So you could pick a number like 6, and it will work for this particular set of sides. You could pick a number like 18, and it would still work for this particular set of sides. But if you choose 5, 4, 3, 2, 1, 0, if you chose 23, 24, 25, or anything past that, they won't work. You have to choose something in between these. I'm going to show you one more. We'll do this one a little bit faster this time. So we're going to assume that x is our smallest side. So that would make x and 18 the smaller sides. So 18 plus x greater than 22. Again, treat this like a regular equation, and I will subtract 18 from both sides. 22 minus 18 is 4. The second thing I can assume is that x is the largest side, which makes these two the smaller. So 22 plus 18 has to be greater than x. Let's see, 22 and 18 is going to give me 40. So x has to be less than 40. That tells me my answer. I can choose any numbers I want between 4 and 40. There is one final problem for you to try. Take a second, try it out on your own, resume the video, see how you did. Alright, let's check it out. You should have assumed first that x is the smallest side, which would mean that 5 is also the smallest side. So x plus 5 must be greater than 12, the largest. Subtract 5 from both sides. that tells me that x has to be bigger than 7. I have to use a value larger than 7. And now we're going to assume that x is our largest side, which makes 5 plus 12 the smaller sides. 5 plus 12 is 17. So we need to choose a number that's larger than 7, but less than 17. Alright, this is a pretty easy set of problems to do. There's really not much going on with them other than making sure that your two smaller sides are larger than the third side. If you keep that in mind, these problems should go pretty smoothly for you.